Welcome once again. My name is Paul Gilbert. I'm the CEO of Quanser, and I'm about to have another conversation in a Quanser Café with a really good friend of mine, Dr. Şirin Tekinay. Thank you so much for taking the time to join me, Şirin, and I know we're going to have a wonderful conversation. But first of all, I just want to tell everybody a little bit about yourself. Şirin is currently the chair of the Global Engineering Deans Council and has been since 2019. And she most recently served as the American University of Sharjah Dean at the College of Engineering. And I believe you have 9 patents to your name, along with numerous publications. And before joining academia, you worked at the Bell Labs, Lucent Technologies, and at Nortel. So bringing to the academic world a lot of practical, real life engineering experience. And I remember listening to or I think it was a conversation you had with someone that I was kind of almost a party to. You were trying to tell the story of years ago when you were, I'm not sure whether you were in research or whether you were at Nortel and you were telling everybody, imagine one day you'll be able to go to a city and you won't need a map. You'll be able to have some electronic device showing you where you were, and everyone in the room looked at you as if you had 3 heads. and look where we are today. I mean, without our phones and devices. And so a lot of the work that you did, a lot of the research you did, I'm not sure if it was 10 or 15. I don't want to age you, but 10 or 15 years ago. That's come to play and works with us every day. So for that, in and of itself, I thank you. But once again, thank you for joining me. And maybe to start with, what I always find interesting in talking to leaders is to just get a sense of what inspired you in the first place to go into engineering.
Thanks so much, Paul. It's a pleasure to be here. I feel privileged to do one of these webinars with you. And to the global audience, what a lovely message to carry as the headline here. If you don't discourage your children from being an engineer, they are likely to become one. So it's all the problems in the world that children see, especially these days. They're engineering problems. And I'm not saying this because I have a hammer and everything looks like a nail to me, but when you look at the Sustainable Development Goals, if not wholly, in great part, they're engineering problems. Of course, when I was a kid, maybe the planetary emergency that we're in, of course, existed, but maybe it wouldn't reflect on a child. But I was lucky that I wasn't discouraged from being inquisitive and wanting to build things and making an impact. And when I said I wanted to be the science officer on a spaceship, I had the kind of parents that did not say there are no spaceships and you can't get on one. They said, great, well then you should be one. And that was the environment I was in. So it wasn't something that motivated me towards engineering or encouragement, as much as the lack of discouragement that unfortunately is the reason why we don't have as many engineers as we should today.
Well, I think
and there is some kind of genetic mutation, I don't know.
Well, I think that kind of leads me a little bit into one of the conversations that we've had many times, and that is the notion of diversity in engineering, of all kinds, whether it's, gender, ethnicity, and so on. And you're particularly vocal about women in engineering. I would love to hear your thoughts about what you do and the challenges you think that we were faced with today moving forward.
Thank you, Paul. For years and years, we've been working on increasing diversity in engineering, and we have tried all the wrong approaches. I'm guilty for some, which is why we should work harder on generalizing our efforts both globally and in terms of the modalities of activities. This is not about encouraging girls to go into STEM fields. It's not about pushing them. It's about pulling them in, for which we need to gender neutralize the professional identity of engineering. As long as it's perceived as a masculine field, we will not succeed in the kind of diversity we need in engineering. We need everybody. As mentioned, I keep going back to making the world sustainable, healthy, safe, and joyful, which are the 4 pillars of the vision of engineering as stated by the US National Academy of Engineering. We need everybody's creativity, innovations, and energy. But the gendered nature of the professional identity of engineering causes girls in those countries where the gender equality index is high, paradoxically, to not want to go into these hard masculine fields. And girls in those countries, such as the Middle East, the MENA region in particular, where the gender equality index is low, the percentage of girls that go into STEM fields at college level is higher than, say, Northern Europe, because the select few self-confident girls now want to go into a masculine field,
Oh, I
so that they will be more respected, because masculine things are more respectable. But then they drop out. There's the leaky pipeline model of diversity in engineering. So now we have more dropouts from the workplace because there's no pull. They've been pushed by their teachers, by their parents to do something difficult and therefore more respectable, and maybe, just maybe, they'll become more independent, but most of them drop out because the professional identity of engineering and the community is so gendered, is so masculine.
So you've gone through this yourself. I mean, you graduated. I mean, you went through undergraduate, you came to North America, you did your postgraduate studies, then you worked for a few companies. What are the kind of things that do you think cause women to drop out in terms of the leaky pipeline, as you call it?
Well, the statistics are there. The family thing and the childcare thing counterintuitively rank at about 8th or 9th when you rank the reasons why women drop out of the engineering workforce. The first 7 or 8 reasons are discrimination, being outcast in the workplace, having to deal with lower expectations, trivialization of their efforts, not getting the credit they deserve, and so on and so forth. So again, it's not childcare, it's not family. That seems to be the go-to excuse for the low percentage of women in the workforce. That is statistically not the case.
It's really more about the environment that they're in and the way that they are treated, or the expectations. And I know that, and I mean, you use some interesting techniques. I think when young women have come to you to present either theses or their projects, you know, and they use it's subtle, but there's words that they use which you try to guide them towards a more positive approach to their
Absolutely.
work.
The word try was forbidden in all of my students' projects and drafts. The T word was a no-no. You don't try, you do. Here's a typical abstract when especially women in engineering start to write. In this piece of work, to the best of our knowledge, for the first time, we try to give a brief overview of some of the approaches. No, 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 no. I tell them, not to the best of your knowledge. This is the first one. It's so easy to do a complete literature survey. Don't come to me before you've done that and say, this is the first time we're doing this. Don't try, do. It's not a brief summary. It's a comprehensive survey. And it's not some of the important things. This includes all of the important things. They're not confident enough, and it sort of seeps through the vocabulary, and it feeds into the already existing low expectations, and it's a vicious cycle. And some of the gender action plans put in place with the best of intentions make things worse. If we have time for about 60 seconds, I'd like to give this wonderful example of Airbus and MIT research. They had about 650-ish, I don't know the exact number, data points. So it's statistically respectable research. empirical research where they decided in order to have about 30% of their innovation team, the R&D engineering team, female, they wanted to have 1 out of the 4 candidates that was already in their recruiting processes, that they needed 4 candidates for each position. At least 1 should be a woman. So you think of those cases where they had 1 woman out of the 4 candidates, they would have a 25% probability of hiring that woman, right? No,
Right.
Statistically it's 0. Those cases resulted in not hiring that woman because the mindset was, this is the diversity candidate that we just have to interview because it's the rule. When you have 2 women out of the 4, the percentage was 50% because that mindset evaporated. The
So
2
the
women that they
mindset.
were interviewing.
So the mindset is in kind of in any setting where you want to bring people into engineering, whether it's academic or whether industrial, you really need to kind of set the goals and bring in a bigger pool, like a larger pool of women, so that you're not putting them in that kind of token position.
Exactly.
Interesting, and it's fascinating that it's statistically proven by Airbus and MIT. So actually, if you one of the things that I know you're very keen on is engineering education reform, modifying the curriculum or the approach to teaching. And this conversation kind of leads nicely into the notion of blended learning. So from my vantage point and for the audience, could you maybe describe what you see as blended learning and what do you think the benefits are for this generation and generations in the future?
Absolutely. The key word there is this generation, because our students are now in engineering colleges and schools, they're Generation Z, the first truly global generation. They were born into technology. They have not seen the world without the internet. And they've also witnessed a lot of terrorism and global problems. So they're truly global and interconnected. They share a global culture. They all know the emojis that how should I say, the more senior ones of us have come to learn. They've been using that as the vocabulary that they've seen. And then in a couple of years, we're going to get the alphas, Generation Alpha, who are now preteens to teenagers already. They're everything Generation Z is in terms of being global. And on top of it, they're activists and they're angry and they're anxious. So we need to get all that energy into engineering. They're very sensible. One of their slogans is "Listen to the science" when it comes to talking to politicians and decision makers about the climate crisis that they feel ever so strongly about. It's their future. So they're extremely respectful of science and technology, but you simply can't sit them in a classroom, lecture them on differential equations, and say, trust me, in 2 years' time, when you take this other theoretical course in your field, whichever program you're registered for, and by that time, this kid who's been building drones since they were 12 has lost all motivation in engineering. So blended learning is the case where students pull information as opposed to faculty pushing information on them. Unfortunately, most faculty are in their comfort zone when they're the sage on stage. That's the
that's the normal approach, right? Yeah.
Exactly. It's but unfortunately, it's becoming the dinosaur really fast if it hasn't already. Students cannot be told, trust us, this is going to be useful to you, when the faculty themselves haven't used the information to build anything, but they've been teaching the same thing over and over again. That era is closed and done with. Students need to pull the information they need to build the things they hope will be solutions to problems. So undergraduate students should be involved in research and development, and they will pull the information from math to physics to whatever discipline of engineering they need, from materials and robotics, and build things, or at least see the path to building things, because especially Generation Alpha is very purpose oriented. And it's a wonderful thing. Their anger and anxiety and all that energy can be channelized into generating solutions. This is what they want.
So, I mean, one of the things that the pandemic has done for, certainly for myself, it's made the global world come together kind of really interestingly. We no longer do you have to travel to do a presentation, to have a meeting. You can have a meeting just like we're having today. I mean, I'm popping to Istanbul today, and I think this afternoon I'll be somewhere in the United States, and maybe later in the day in China. Are you able to use that with your students as well? Have you been able to think through some of those international oriented kind of approaches?
One thing we did as the Global Engineering Deans Council in response to the pandemic was to launch the Virtual Internship program. When it became clear that the pandemic was here to stay past the spring break, we rolled up our sleeves and said our students need internships, and they need internships for credit, and they need these credits for graduation, and we will not delay our students' graduations or stop their clock to graduation because of the pandemic. Well, how do we do that? Things have to be virtualized. A lot of the companies that offered internships were too busy trying to figure out their own work from home schemes. So internships were not terribly high on their radar, most of them anyway. So we did this for students by university virtual internship program, and some of our corporate members did pitch in with virtual internship opportunities that we launched the platform for advertising globally. And so without prohibitive airfare, without the need for obtaining visas, which might take longer than the internship itself for some of the students elsewhere on Earth, we were able to have 36,000 students were interested. We know that's the number of clicks we got on the website. The actual internships to be completed will be counted towards the end of the year. That's in the hundreds, but we will continue. And also now we started to pull the Southern Hemisphere together, because we keep referring to the summer internships, and most of us, I'm guilty for this, refer to the months of June, July, August, whereas on the GEDC Executive Committee, I have excellent colleagues from Monash University in Australia, University of Pretoria in South Africa, and I'm sure I'm missing some others from the Southern Hemisphere, and to them, it's the other way around.
Winter,
So now we're able to activate twice a year summer internships.
Oh, so you had a kind of a second one. You had the summer that we would call the summer in our world, and then for other parts of the world they had a second wave. That's fascinating. But you said 36,000, and I know we were fortunate. We work with Krishna, our good friend Krishna in India, and I managed to have I think about 20 interns that we worked with through universities in India. Compared to what we'd normally be able to do, that was probably 10 times as many as we'd normally be able to do. So do you think that the lessons that we've learned in terms of internships is one, the other one is the blended learning approach, using a virtualized environment, having access to labs, obviously from my perspective, that's something that which we were very conscious of. Do you see a fundamental shift? Do you see like a big shift now that when the pandemic's over to a newer modern way of teaching? Or do you think the pendulum will swim right back?
Absolutely. I think we should stop thinking of virtualization of experiential learning as a means to simply mimic what's available face to face, because that's a losing battle. You're setting the bar too low. I think going into the virtual realm has its own advantages over face to face education. I'm the first to say engineering education is in large part experiential, and you can't virtualize everything. There are some labs in chemical engineering or civil engineering that students simply have to be physically present at. But again, there are so many things we can do with virtualized labs that we can't do in real labs, such as the age-old problem we've been having with students developing intuition, looking at theoretical foundations and understanding the laws of their discipline that they govern. Now you're able to, first of all, have a virtual environment where you have an immersive, interactive, maybe augmented reality type or virtual reality supported environment where you're mimicking the real lab, but also you're able to fly the mathematical foundations governing what they're doing right there and then in front of their eyes so that they see the direct relationship. Here's something none of us were able to do from the classroom to the lab. We've been trying to match these in our students' minds. Some do, some don't.
Well, I mean, if you know, from my vantage point as well, and I know you've had obviously many conversations with industry. You come from industry yourself, and that's the modern way of engineering. I mean, the modern way of engineering is to talk about using digital twins so that you can understand and develop prototypes faster. You can actually do a lot of theoretical discovery, and then you've got to figure out what's the difference. What's the 5 or 10 or 15% difference between the digital world and the thing that you want to actually develop? Do you see this as something which universities can build on in terms of attracting students and building their portfolio of capabilities when they move on to try and get a job when they graduate?
Absolutely. And again, industry has been the locomotive of this. Uh, Imagine when we're educating pilots or astronauts, we've been using simulators, immersive environments, because
Right.
the real lab would be ever so expensive. So it's not a difficult mind shift. It's sort of the comfort zone that we have to push people out of. And again, industry simply cares about the employability of graduates. So the collaboration between universities and industry on curriculum will be extremely useful there. And again, hopefully when this pandemic is over and done with, we will have these virtual tools as valuable tools, and universities have to reinvent themselves. This is an opportunity. They have to reinvent themselves in a hurry with asynchronous and synchronous uh, education modes and global student bodies. 80% of the global engineering student body are studying in other countries, not in their native country. So it's an extremely global student body. And to serve that student body, delivery online or virtualized delivery is extremely powerful and useful.
So going back to what you said really earlier on, is your notion or your desire to have students get involved in kind of research-based kind of studying from day one. How do you go about implementing that? Have you seen any good examples of where people are able to bring students in? And year one, traditionally, it's the sit in a lecture hall, listen to concepts and theories go flying by your head. Other universities are beginning to try and put things in their first year. What are the kinds of things that you've seen or attempted yourself?
Well, you know how universities have this freshman foundation building year to bring everyone on the same page and so on. And then there's also this, well, engineering students should go take some humanities classes, they're too dry otherwise, and so on. All right, that's great. No objections there, but everyone on a university campus, whether they're engineering students or not, should take some engineering courses also. Everyone should understand coding, computational thinking, complexity, whether as advanced as the human brain or the social network that they use every day. They should have some notion of complexity, so that engineering is not this insular, difficult thing that these students in that ugly building in the corner do when the rest of the university is happily having their engineering friends code their program their uh, smart homes and whatever. The whole society needs to have a notion of computational thinking and complexity and some basic engineering concepts. So the bringing everyone to the same level the first year should really prompt teamwork towards projects that students have cared about since they were preteens. So more and more maybe extracurricular activities, honor societies on campuses, engineering clubs should be more inclusive and multidisciplinary, so that engineering solutions, generating engineering solutions and co-innovating is fun and it's part of the engineering culture.
Yeah, it's something which I've talked a lot about when I present to students in engineering. I often talk about, you know, career progressions that they are thinking of, and it goes from, you're going to be an engineer and you're going to spend your career as a design engineer, and other people branch up. You might go into business, you might go into law, you might go into politics. And one of my biggest fears right now is the level of engineering understanding in the political spectrum, right? And if you could get people to understand that they should have a voice, or the scientific and engineering community should have a voice, and encourage that. So those, I agree with you, bringing a breadth of experiences into an undergraduate life, you know, from day one is really, really interesting. I'm going to ask a bit of a controversial question because this has come up a number of times. We have in engineering silos, disciplines. We have mechanical, we have electrical, computer science, chemical, and so on. What's your take on that? Do you think that model is still something that's relevant today?
Well, it makes coding the courses easier. I think we need to go into more modular curricula where students can grocery shop and put the number of credits they need for accreditation and graduation in their baskets, but consciously choose the skills and knowledge that they need to become what they want to become. This is easier said than done, even when you reinvent your curriculum as such. Faculty will ask you, now I'm talking as the dean, they'll ask you, so how are we going to do the assessment? How do we grade these students? So when everything else is so progressive, you still have 2 midterms and a final, and the final has 40% weight, blah, 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 blah. The students will come to you and say, is this going to be on the test? Whose answer for my students now is always yes. And then, will you ask the same questions you did last semester because somebody got hold of the archive? I say, yes, I'll ask exactly the same questions. Did not change them a bit. I changed the answers. So you have to do something new. There's a lot to be done. And that's why global platforms such as this is extremely important, because we as engineering faculty should, and administrators should, think about how to evaluate and assess teamwork and project-based learning. We do not know yet. We're
Yeah, I
still.
mean, you bring on the discussion of assessment. I think that's incredibly important, and I certainly know that when I'm hiring people, um, I take it for granted that they have the technical skills based on the university they've gone to or based on the courses that they've done, and I'm much more interested in their personality, the characteristics they bring to the company in terms of teamwork. And I know it's difficult, but from an administrative perspective, to try and create the programs that are going to be attractive to industry, at the same time create students who are going to be lifelong learners and going to be able to adapt and be able to think. I mean, there's a lot of things that I think have to change. but I'm an optimist. I mean, you and I, we've been to multiple conferences where we see leaders in the field. How do you feel, just in general terms, in terms of the direction that universities are going right now? Are they moving fast enough, do you think?
No, but we're speeding up. So I'm happy with the acceleration. Not fast enough, but speeding up, because the necessity is palpable. Those universities who are capable of doing this are way ahead of the curve. Even the traditional ranking systems that are so coveted by universities are changing. The United Nations has a UN academic impact, which is prestigious to be a member of. Times higher education ranking systems have now evolved to accommodate impact ranking, which directly measures universities' impact towards sustainable development goals. I really hope these, and of course, accreditation, such as ABET or ABET equivalents under the Washington Accord, are accommodating more and more project-based experiential learning for engineering students. So all of these are making me very hopeful, but what I'm most hopeful about is student engagement and leadership.
Mm-hmm.
Students know what they want. They're increasingly purpose-oriented. So if we have college and school administrators who are flexible enough to accommodate, to effectively and productively channelize students' leadership, they'll be the winners, because students really want to learn. They are not the work averse, grade greedy students of the 20th century. That model was maybe true to higher percentage, but right now that's a very low percentage, I'm very proud to say. Students want to make a difference. They chose engineering schools to not get good grades and graduate, but to make a difference. And that kind of motivation needs to be channelized well.
So, you know, one of the things which I'm really happy about in this series that I'm doing, meeting leaders like yourself, is to, you know, the conversations we might have with 200 or 300 people at a GEDC conference. I'm hopefully getting out to many more thousands of people that can have this conversation. So that theme has come out loud and clear to me, and that's advice. I think you're giving the advice for administrators to listen to students. The student voice is something which is really powerful.
Absolutely. And of course, it's not just the small schools, many little engineering clubs. They might be small in numbers of students, but we have global engineering student organizations such as SPEED, the Student Platform for Engineering Education Development, BEST, the Board of European Students of Technology, which is no longer European, it's actually quite global. Please hook in your student organizations to these global organizations. Their impact is amazing, and students are leaders when it comes to making productive use of social media and holding events and conferences.
And so you also, I mean, this goes without saying, you're encouraging students to join those groups as well and become more vocal in what they can do in the future. You know, Şirin, this conversation has already gone so fast. I can't believe the time already. I really want to thank you for the work that you do. I know you've been a huge kind of guiding spirit for so many people. And I know you always say this to me, you take the baton from somebody else and you pass it on, and you're building on the shoulders of giants. But given your background and what you've done and taken to the global world, thank you very much indeed. And on a personal note, the fact that I can go to all these countries around the world, pull out my phone, and I know where I am, and if I want to go to from A to B, I always tell my kids now, I know somebody that was involved in the technology that made that happen. So thanks for that as well.
Thank you. This has been such a pleasure. Thank you very much, Paul.